This project has been both the most fun experience and the most soul draining at the exact same time. So currently, I'm doing a degree in bioinformatics, and one thing I'm trying to do right now is using computational tools to discover a whole virus. I might be cooked. What are the guidelines for what I'm trying to do? So first, I'm actually given a sequence of an RNA-dependent polymerase, which is essentially just like the backbone of the virus. It's what actually replicates the virus genome. So I'm given the palm print sequence, so like the most important region of that protein sequence, and from that protein sequence, I need to be able to see if I can discover a virus out of it. So I just got a crazy new development. So I put some of the runs in a spreadsheet, and okay, obviously you got this species of fungus, this is a fungus as well, and this is actually a wheat plant. And what's really interesting is these two funguses are actually pathogens, and they actually infect this wheat plant. So yeah, that's actually really interesting. So my virus, maybe it somehow contributes to the infection of the wheat plant, maybe? So that's now kind of the basis of what I got now. So now the question is, how do I actually show it, you know? So I think there's nothing to do but go to step 1, assemble the genome. Yeah, I don't know if it's just me, but this assembling this genome, my gosh, it's difficult. Oh my god. So the first idea that I had was, okay, I'm just gonna take the Logan assembled config files that he gave us, and I'm just gonna run them through tblsn using this bash script here. ChatGPT may or may not have helped me write. And then run some code on it, and then extract the sequences with the highest hits, which I thought should work, but then it gave me files like this. This is not even close to long enough. Genome, but after trying to do the Logan assembly, I'm now realizing from this Discord server is now telling me that, oh no, Logan assembly apparently is not accurate. So I need to use RNA spade. We're gonna try running RNA spades again. And yeah.
One eternity later.
So after waiting for 4 hours, the program crashed because it was using too much RAM. So the second solution I'm gonna try is, instead of using tblsn on my terminal, which my guess is I might not be doing it correctly. Maybe there's just error in the code. It might be easier to just go on the web server and do it. Kind of, my desktop's a little messy right now, but like I actually was able to find the protein. So this is the alignment sequences that I got from the tblsn web server. And actually, if I take this first sequence, just copy it, Control F, there is a perfect match. And this sequence, once I get this sequence, I actually found out to be my actual virus genome. Is that maybe that because there's this new virus that's already been discovered, PSV5, and it's already known to actually infect Puccinia striiformis, this fungal pathogen that does go on to cause the wheat rust disease. So that they've already tested that, they've already done the wet lab experiments to confirm that. So what I'm going to try to do is read this paper, see if there's any relationship, but then also see if, hey, maybe do these viruses interact in some way? So can my virus's RDRP actually maybe form a complex with this virus's RDRP, or maybe something like that? So I'm going to try to use a bunch of computational tools to see if I could get a relationship that way. Analyzing the OR sequence, I'm trying to look for kind of similarities to this novel virus just to see, and there actually are a couple similarities. Most notably, So obviously it is very clear to me it's a narnavirus because if you look at, there's this really long open reading frame here. If you can see it, it's ORF9. It's titled ORF9, and it basically spans the entire genome. So that's really good. And then ORF12 is actually, notice it's in the reverse direction, and it also spans pretty much the entire genome. So that actually indicates to me, like based off previous research, like in narnaviruses, it's actually an ambigrammatic virus. So that means there's just this reverse open reading frame that just spans pretty much the entire reverse of the genome. Sometimes this can code for a protein. I'm going to see what protein it produces and then see if that protein actually does something. But that will be really cool to kind of like analyze. And so, I just found the ORF. Well, I've just hit rock bottom again because my Interpro, which is supposed to give me, which is a tool you put in your protein sequence and it pops out all functional domains. Yeah, it can't identify any functional domains, giving me nothing. So overall, after getting the open reading frames, essentially I was able to conclude, one, that it was indeed ambigrammatic, and that its sequence was actually relatively similar to the PSV5, the already discovered virus, and also their proteins had some structural similarities to 2, and that's just because I just put it into peptide info basically, and I just looked at the hydropathy plots as well as kind of like where the charged residues are, and they matched up fairly decently. So their function seems to be pretty similar, but I can't see if they actually have an interaction together. So I'm going to try using AlphaFold now to see if I could get anything useful. So my process essentially was to just use AlphaFold 2 to get the 3D structures and then put it into Pymal basically. And then what I was able to get was the structure of microvirus. So obviously the motifs are colored. And then the structure of the virus that's already been discovered, and kind of form this multimer complex. And then if I actually measure the charged residuals, I can actually view where potential salt bridges might be. So these can kind of be clues as to where, if they do interact, where the interface might be. It doesn't seem like there's much though. So obviously, when I started with the viral genome and the ORF analysis, I was able to determine, kind of what it's able to do, which is in fact cause wheat stripe rust disease. And I was also able to figure out that, hey, it's ambigrammatic, it's a narnavirus. After that is where my research kind of takes a nosedive. There were so many things I wanted to do, like I was going to simulate molecular docking and bind an RNA with the protein, but nothing just worked out. It took way too much data to render files. I had to get licenses. So overall, what's my final reflection on this project? Research is hard, man.